Welcome everyone, and thank you for taking the time out of your day to join us for our new product rollout event covering our R-Series radar lineup. My name is Christopher Winbun with Teledyne FLIR's Sales Enablement Team. Joining me as co-organizer for this event, Adam Murphy, our Director of Product Management, responsible for the overseeing and the release of the new R-Series line. A quick public services announcement before we get started. At the bottom of your Zoom console, you will see that there is a questions pane that can be accessed. This is your portal to ask questions during the event, so feel free to do so if you have any questions or need clarification on anything related to the R-Series. Adam and others in the Sales Enablement team will directly answer specific questions that come through the questions pane. We will also have a period of questions and answers at the end of the presentation if time allows. So with that being said, I invite you to sit back, relax, grab a cup of coffee as we will begin our presentation now. So our journey today is going to start with an introduction to radar. Then we're going to talk a little bit about the Elara R-Series radar, followed by an in-depth analysis of benefits of radar technology and a quick look at the specs of our new Elara R-Series radar. Then we'll move into the target markets in the security space. We'll take a little bit of time towards the end to talk about system integrations and ordering information. So let's jump right in and start talking about how radars work. You can see in this graphic at the bottom of the slide that radar is based on a very simple concept. Radio waves are sent by the radar system, and then any echoes that bounce back to the radar receiver indicates that something's there. When there's no echoes returned, there's no targets present. The Elara R-Series radar is a powerful addition to our perimeter protection solution. With up to 400 meters of detection range and 90 degrees of horizontal field of view, customers are able to monitor larger areas with less equipment. And combined with our perimeter protection solutions like PTZs, analytics, and our UVMS, our customers now have access to one of the most advanced perimeter solutions on the market today. Our advanced perimeter protection solutions can detect potential threats and track them at even greater distances than we could prior to the addition of our new FLIR R-Series radar option. So in the next few slides, we're going to break down some of the benefits to our customers that utilize radars in their perimeter protection solutions. These benefits include improved response time, large area coverage in any weather condition, simplified geolocation of intruders, automatic PTZ tracking, and of course, how affordable and maintenance-free a solution utilizing radars can be. So one of the first things that we're going to talk about is improved response time. Improved response time leads to faster threat mitigation. The further out we can detect a potential threat, the more time we have to respond to that potential threat, which means defensive procedures to intercept intruders can be deployed long before the perimeter can be breached. Check out the graphic that we've laid out here, which really puts it into perspective for you. This shows how important it is to get that initial detection as early as possible. Time is critically important in any perimeter detection solution. So next, I'd like to share a video with you to put a couple of things into perspective. So the video that we're going to watch here is an example of a very foggy, cool California morning, where the temperature contrast across the scene is not ideal for thermal detection. Now, you'll notice that in these conditions, the radar is going to do an exceptional job picking an individual. Now, if you look at the right-hand side of the screen, you can see the individual already being tracked by the radar. And if you watch over here in the thermal image, that individual will pop up here shortly. So just Give it a couple seconds, and we'll see at about 58 seconds after the radar picked up the individual, that individual will now be in the scene. So again, getting a little bit closer here. Now I'm going to come back on the air and just mention that you can barely make out the individual coming into the field of view. And right about in just a couple of seconds, we're going to get that detection. Now, everybody's probably sitting there going, wow, that was a lot of dead air. Can you imagine if you were sitting behind a console and you didn't have that radar to detect that individual that far in advance? It's a lot of downtime. The next little clip here is going to show a vehicle. So this vehicle is going to move rather rapidly towards the camera. And again, we're talking approximately 25 seconds after the radar has made contact with that vehicle, where we will see it come into the scene for a split second into the thermal camera. So again, 25 seconds, that is a lot of time. This is why the R series radar is a great complement to the thermal and visible analytic cameras that can be incorporated when protecting perimeters. Next, let's touch on large area coverage applications. In large area coverage applications, pairing a radar with devices like PTZ cameras can provide a more robust perimeter security solution. Now, radar can detect targets at great distances over wide areas, and we can pair any number of radars together with even a wider area of protection. Now, once the radar detects a target with specific geolocation coordinates, the PTZ, or PTZs in some cases, can then be automatically programmed to pick up the target and continue tracking based on the radar's continuous location updates. And while we always want to have our eyes on the fence line, with our thermal invisible fixed cameras and PTZs, radars extend our ability to detect potential threats beyond the capabilities of perimeter surveillance solutions comprised solely of cameras alone. Now let's dive in a little bit deeper about geolocations. Now, because radars let us easily geolocate a potential threat, this allows for GIS mapping capabilities, like those that are found in our FLIR UVMS. Now, this shows operators exactly where that target is and alerts the operator with automatic camera views in proximity to where the detected target is, so that they can track the potential threat. And conversely, this same geolocation technology can be utilized to ignore targets in areas where they have been excluded from the area of interest, lowering false alarm rates and focusing on what is truly important. Okay, so we're going to take a quick look at how PTZ tracking can be a huge advantage when working with radars. So we're going to look at this to really put some additional perspective on it. So in this image, the first thing that you'll see is on the right-hand side, we have our PTZ, and on the left-hand side, we have our GIS map. And you can also see the alarm zone, which is right here over the parking lot. It's maybe a little bit difficult to see, but there's a red boundary in this area. So that zone, it's about 100 meters or so. Now, you can see at the bottom right-hand side that the Elara R series radars are compatible with the FLIR PTHD series, the DX series, along with our Quasar 4K IR PTZ. So there's a lot of options that can be deployed based on what your customer is looking to achieve with their radars and if they'd like to incorporate PTZ tracking. Now, taking it a step further, just real quick, this shows that basically the radar and PTZ pairing. Now, you can see the GIS map integrated with the radar in the bottom left pane, and it has identified a target. And in the second pane, where we have our PTZ camera, the handoff has taken place, and the radar and PTZ work together to track that target once they've gotten into that alarm region. Which brings us to automatic target tracking modes that can be selected within the PTZ's camera setup menu. Now, you can choose from many of the different options depending on what you want your PTZ to do. If you want the PTZ to track the closest target or the last target identified by the radar, do you want the PTZ to scan between targets on different radar tracks? Now, all of these things can be programmed to work as you need them based on the individual perimeter protection applications. Now, one additional thing that you want to note is that all configurations in all of these configurations operators, they can manually override the PTZ to manually focus on areas of interest, right? In deeper integrations, when you're including the, let's say the FLIR detection systems plugin, you can override any of these modes and manually select the target to track directly from the GIS map. And of course, we get to the affordability and the maintenance of the unit. Now, one important thing to understand about radars is that the components are both affordable and relatively maintenance-free. As there are no moving parts or hardware, it's ruggedized with IP66 certifications for ingress protection. Another factor in relation to affordability is that these Elara R-Series radars get their power over Ethernet. Now, this can significantly reduce the deployment costs where a separate dedicated power source is needed. So let's quickly talk about the specifications of the R-Series. So just a quick overview, there are two different units that are listed here. There's the R290 and the R190. Now, both units look the same. There's no physical differences between them, but there are some regulation differences in where we can market these particular units. So let's dive into that just a little bit more on the next slide. So here we have the R290 and the R190. And the main difference between the two units is, again, where we're going to market these. The R290 can be sold into and operated in countries that follow the FCC standards. And the R190 can be sold into and operated in countries that follow the CE standards. Now, real quick, I'm just going to back up for 1 second to this last slide that we're here, and I want to point out a couple of quick differences. Now, for the most part, a lot of what you're seeing here is the same. I want you to take note on a couple of differences that you'll note between the different units. And of course, this is because of the power level of the units and what we can actually output here. So human detection range, you'll get about 200 meters on the R290. You're looking at about 125 meters on the R190. Vehicle detection at 400 meters on the R290, whereas we're looking at about 300 meters on the R190 radar. So those are going to be essentially your biggest differences in terms of performance between the two units. Okay, so now let's fast forward over to our next slide and begin talking about some of our target markets. So what do we need to be aware of? Now, because radars send out radio waves and listens for echoes that bounce back, it works best in large open areas without too many large objects that can obscure approaching targets from being identified by the radar system. Anywhere that you have a facility that sits in a remote region, like prisons, airports, substations, radars can be used to increase the distance that potential targets can be identified. All right, now the flip side of the coin are applications where radar is not the most effective. Now, you can see in the substation on the left, lots of clutter within that can get in the way of the radar beams. Now, keep in mind that radar is a line of sight perimeter solution. So it will perform best in large open areas without obstructions, like you see here in this substation. Varying topologies can also be problematic for radars because, as I've already mentioned, radar is a line of sight solution. Just like what happens if you point a flashlight in the direction that is obscured by rolling hills or tree lines, radar is not going to have the ability to see what is behind any of those obstructions. Now, in the third example, where the radar would not be an ideal application is with large metallic buildings or structures at varying angles to the radar. The return echoes can become skewed because the angles of reflection become scattered. Objects at 90-degree angles will echo back much more intensely than objects at varying non-direct angles. And finally, when designing a radar solution, you have to take into consideration that in some situations, like this loading dock area of a distribution center, objects may appear from time to time that can obstruct the radar beams. So if they're mounted too low, that could be problematic. Now in this example, these trucks can block the line of sight when they pull in front of the gates. In situations like these, mounting height of the radar is an important factor. So now let's talk about something that should interest everybody on this call, system integrations, and how our radar works with the FLIR UVMS and of course other VMS solutions that are out there in the market today. So you could see here, we have two paths. We can use a static mapping function as seen here on the left that uses ONVIF RTSP streaming where the radar is treated just like a camera in the VMS. Now, during the setup process, you download a JPEG image, just like an image from a Google map, and scale it to the radar. Upload it, and the radar stores and uses this map. The radar also streams the map with all of the targets, just like it's a video feed coming out of a camera. The information that's streamed from the radar to the system is an MJPEG stream, which is the map with all of the content. The overlays for the range, the target information, the zones for alarms, exclusions, the PTZ field of view. You'll notice that there's a blue cone and a red cone on this image, with the blue one being the visible camera. The red one is the thermal, and they move in real time based on where the target is and what the zoom setting is for the camera. The position of the radar and the camera are designated on the map. As I mentioned before, this is not interactive. It's just a stream. You can look at it and get perspective on what's going on. You can't click on it. You can't do anything with it. But the nice part is this can go to any VMS because it's literally a video stream. Okay, so the upgrade from this is the GIS map integration that you can see depicted on the right-hand side. This image shows a fully interactive URL-based map where you can click on targets. You can command the PTZ to follow specific targets in any manner you choose, first target, last target, closest target. It's more feature-rich and allows the operator using the VMS client to use all of the integrated features of the solution either together or separately. GIS map integration requires a plugin to integrate the radar, both in our own UVMS and other VMSs like Genetec, which uses an RSA plugin to integrate our radars into their system. So in the next few slides, we're going to show a few example systems and configuration scenarios. In a one-to-one system, where the camera and the PTZ run into a switch and provide a video tile into the system, it's this link here on the right that's perhaps the most critical piece of the integration, as it is the radar and the PTZ that are directly connected to one another. So within the PTZ setup, on the radar tab, you can identify a radar in the system that you want the PTZ to follow. Now in this next example, we have multiple radars. Now, what the PTZs do in this case is they listen to the radar and say, okay, send me the coordinates of any target. If there are more than one radar and there's overlapping beams, the radars are smart enough that when you set them up, you can say, this is radar 1, this is radar number 2. I know that is my field of view and that there's this overlapped area. And any targets that go into those overlapped field of views, I will consolidate into a single target. And I will send the PTZ to that one set of coordinates so that they're not getting two slightly different sets of coordinates from two different radars. So now on this slide, we're looking at a single radar with multiple PTZs. So when we integrate more than one PTZ to the radar, it gives you multiple different vantage points. Maybe your two PTZs are on either side of a building where you have the radar overlooking the front. You might have a line of sight obstruction on one PTZ, but have a better vantage point from another PTZ. Each one of these PTZs just wants to follow the target from the radar. The radar unit talks to both PTZs independently and can tell each of them which target that each PTZ should be tracking and follow. Okay, so the next example we have here is multiple radars and multiple PTZs. When we have multiple radar units covering a side-by-side field of view, those two radars can be linked together so that they act like one radar. And then you can link that PTZ to that one radar. So now you can have a 180-degree radar field of view instead of just a 90-degree field of view. The PTZ in this case just follows the instructions that will be sent to it based off of what the new super field of view would see, regardless of the number of radars. It can be 1, it could be 2, it could be 50. We consolidate that information and then it can send that to the PTZ so the PTZ knows what targets to follow that come back from all of those 50 radars in that type of an example. Okay, so one last quick example, and this is just to kind of reinforce what we talked about on the last slide. So here's a perfect example of a 20-acre oil and gas facility with multiple R290 radars and multiple Elara DX PTZs showing each field of view and how they all overlap to cover an entire area. Now, keep in mind that we talked about this earlier. Multiple side-by-side radar units can be linked together, and PTZs just treat them as one radar. So this makes the communication to the PTZ more efficient and reduces the potential of the PTZ thinking that the same target seen by more than one radar unit with overlapping fields of view are two different things. Okay, so next let's jump in and talk a little bit about the ordering information. So just a quick rundown on ordering information, of course, including the various part numbers for the Elara 290 and the Elara 190 radar. And then of course, we also have an array of accessories that can also be ordered with your radar depending on how you plan to mount it. So again, we have a pole mount adapter. We've got a corner mount for the corner of a building, 180 wall mount. Now, actually, this one is kind of unique, so I just want to pause here for a second. The plate that you see down here for the 180, this can accommodate two radars. So again, if you're looking to maybe sweep a whole front of a building, you can get one mount two radars to it and get that 180, just kind of like what we talked about on that last slide versus just a single 90-degree mounting. So again, two radars on one plate, save you a little bit of time on installation. So excellent mounting option there when you're looking at using multiple radars. Now, the last piece we also have here, of course, we do have those PoE injectors that can be ordered to power your radar as well if you don't have a PoE enabled switch to be able to supply that power. So this here is the PoE plus power supply that we do offer. One of the most important questions that you may have right now is, When will the R series from FLIR be available? The R series will be generally available during early Q1 of 2022, so just a few months from now. So a quick rundown on the warranty for the R290 and 190. The R series comes with a 3-year warranty that basically it's the same warranty that our fixed thermal camera profile provides. So there's some added additional information if you'd like after the webinar. You'd like to be able to access the links directly from here to get the warranty information. You can do so conveniently from this presentation.